Han beskriver dramatiken i fysiken och mystiken i matematiken. Och hans stora kärlek till vetenskapen gjuter nytt liv i en gammal till synes uträknad ekvation. Att delad glädje är dubbel glädje.
Okay, this is Homer Simpson, and I challenge Flanders, Lenny, and Flanders again to do the Ice Bucket Challenge.
Vad har egentligen Homer Simpson och matematik gemensamt? Det är något som den brittiska vetenskapsjournalisten och författaren Simon Singh reder ut i sin nya bok Räkna med Simpsons. Redan som liten drömde Simon Singh om att bli vetenskapsman. Han doktorerade i partikelfysik men insåg snart att han aldrig skulle bli någon framgångsrik fysiker. Istället sadlade han om och gjorde en dokumentärfilm om Andrew Wiles, matematiken som lyckades med bedriften att bevisa ett av matematikens mest kända problem, Fermats stora sats. Berättelsen blev också en bästsäljande bok, Fermats gåta. Efter det har han skrivit flera pedagogiska böcker om historiska vetenskapliga händelser, som granskningen av alternativmedicin i salvekvick och kvacksalveri, världsalltets början i Big Bang och kryptografins historia i kodboken. Och nu tar han alltså med oss till Springfield, för familjen Simpson plus matematik är lika med sant.
Whenever I talk about The Simpsons and I say to people there's tons of maths hidden in The Simpsons, people are always shocked and surprised.
Flera av manusförfattarna är förälskade i siffror och har avancerade kunskaper i matematik. Och många gånger har de lyckats smyga in matematiska gåtor i avsnitten.
Please welcome Simon Singh. Please have a seat. I'm so glad to have you.
It's nice to be here.
Yeah. So, you've written this book about the Simpsons and their mathematical secrets. So first I have to ask you, did you do all of this just to become a cartoon character on The Simpsons?
I hope one day. I did an event, actually, with some of the writers of The Simpsons, who are also writers of Futurama. And they did edit a little bit of animation where I was mentioned in Futurama, but that's the closest I've come to actually appearing in the show.
It's a good life goal, though.
Yeah, absolutely. There are many Nobel laureates and many great scientists, from Isaac Newton to Stephen Hawking to Stephen Jay Gould. I would love to be in their company.
Yeah. But how come there are so many mathematicians writing for this show?
It's a really astonishing fact. We have people with undergraduate degrees in mathematics. We have people with master's degrees, PhDs. One chap, Jeff Westbrook, was a Yale professor. And there are so many of them that there does seem to be a link between mathematics and comedy. And I asked all of them, I interviewed them about a year ago, and I said, why do you think you've ended up becoming comedy writers, and not just comedy writers, but comedy writers on the greatest, most successful TV show in history? And they came up with different ideas. One idea was that if you love mathematics, then you love the logical. And if you love the logical, you like stretching logic and bending logic and even breaking logic. That takes you to the illogical, and the illogical can be humorous. One idea was that building a joke is a bit like building a mathematical proof. You're following a series of steps to reach a conclusion. And if the conclusion is absurd, and in fact in mathematics we have something called a proof by contradiction, or reductio ad absurdum. So you have this idea of absurdity within mathematics. I mean, to be honest, there's no obvious answer, but I tried to get them to explain as best they could.
Well, actually, the math in Simpsons are often freeze-frame jokes, like 1 second jokes in the background. So how come you discovered this hidden math in Simpsons?
You're absolutely right. When the writers started working on the show, Matt Groening, who came up with the whole concept, said, put as much maths as you want into the show, but don't scare anybody, because obviously a lot of people are scared of maths. So when there's a really complicated equation, it's there for a flash, for a moment, and you have to really look carefully. So if you know it's there, and you love maths, great. If you don't like maths, then you never even notice it's there. I noticed it because in an episode called The Wizard of Evergreen Terrace, we see Homer Simpson, who wants to become an inventor, writing up some equations on a blackboard. And one of those equations relates to Fermat's last theorem. And I've written a whole book about Fermat's last theorem, so when it appears on a blackboard, I couldn't miss it. Even though it was there for just a moment, it lodged in my brain. And then I rang up the writer of that episode, a chap called David X. Cohen, and I said to David, you know, how come you put maths in the show? And he said, well, you know, that's not the only maths. There's much more maths, and all the other people are doing it as well. And then I just spent a lot of time watching a lot of The Simpsons. And
not a bad job.
No, no. My wife is writing a book at the moment. She's writing a book about a British suffragette, an Indian woman who was a suffragette in Britain. And so she goes to the archives every day and she transcribes these diaries very, very carefully and comes home late at night, having done all her research for her book, and she watches me lying on the sofa watching The Simpsons doing my research for my book. So
I'm working, dear.
Yeah, I think I had the right book to write.
Yeah, but you describe in the book how these script writers' meetings, I mean, they spend like hours or even days discussing and calculating these advanced mathematical problems that will, I mean, be on the show for a second or so. So is it, what's the point? So,
no, yeah, they do take it very seriously. So even something trivial like pi, you know, we all studied pi at school, we all know about pi. In The Simpsons, there's an episode where Apu says he can memorize pi to 40,000 digits. Now, today, you could look that up on the internet very quickly, but when the Simpsons writers wanted to introduce that idea, there was no easy way to get the 40,000th digit of pi. So they actually sent a fax. It was a very long time ago. They sent a fax to a world pi expert, a mathematician working at NASA, and they corresponded with him, and they got all 40,000 digits delivered to the studios in Los Angeles. So they really take it seriously. They go away, they calculate the formulas themselves, they ring up experts. They really care about it. And I think the point initially was that they are mathematicians, or they love mathematics, but they're not mathematicians anymore. They're writers. And this is their way of still expressing their love they have for mathematics, I think.
It's not only Simpsons that change our view of science. I heard that you got Katie, the pop singer Katie Melua, to change her lyrics for you.
Yes, yes. So,
what's up with that?
Well, she wrote a song called 9 Million Bicycles. A lovely song, 9 Million Bicycles. And the second verse says, we are 12 billion light years from the edge. That's a guess. Nobody can ever say it's true. And that's why I know that I will always be in love with you. OK? That's how the line goes. Now, that verse implies that the universe is 12 billion years old. It's not. It's 13.8 billion years old. She says it's a guess. In science, we don't make guesses. She says, I know that I will always be with you. Well, you know, I can't trust a word this woman says at this point. So I rewrote the lyrics. And my version of the lyrics said, we are 13.8 billion light years from the edge of the observable universe. That's a good estimate with well-defined error bars. And with the available information, I predict that I will always be with you. Now, my lyrics aren't perfect, but they were an improvement. And what was great was that Katie Melua loved science. She was in the astronomy club at school, and she read my article, she read my lyrics, and we met up the next day. And she re-recorded her song using my lyrics, which is one of the high points of my career as a writer. Yeah. I'm now a songwriter, I suppose. Well,
actually, you and I have met once before. I'm not sure that you remember, but you were here with your book on Fermat, and you had this lecture on math. And I got so moved, and I cried so hard that I couldn't talk to you afterwards, right. And I couldn't ask you to sign my book. So what made you this incredible link between difficult science and maths and us ordinary people?
I don't write difficult books. Okay, that's people say to me you should write a book about quantum physics, and I can't write a book about quantum physics because it's really difficult, and I struggle to understand it myself. So the great thing about Fermat's last theorem is that the problem is quite easy to pose. We have a 350-year-old solution that nobody knows where it is, so we have a buried treasure. we have a 9-year-old boy who dreams about solving it. So we have a great human story of childhood obsession and ambition. And so I wrote that book because I had a great problem, a great history, a great hero. And when you have those things, the story kind of writes itself. The job is just not to mess it up. And it's the same with The Simpsons and mathematics. You know, I love The Simpsons, and I think a lot of other people do as well. I love mathematics. I think some people do as well. When you put the two together, it's a really easy book to write. For me, there's no point just telling stories if you're not conveying the mathematics at the same time. So my secret is that I pick easy, good stories. Finding easy, good stories is difficult, but when you find them, then you can't resist them.
Yeah, because you really pick good stories. Because for me, I've read all of your books, and I don't always get the math. Well, I very seldom get the math, to be honest. But I always get the stories. And the stories, I mean, there are stories about the history of science containing love and death and sacrifice. Yeah. And, I mean, it's great drama. I love the one about the Greek ancient math teacher being ripped apart by an angry mob. And...
Yeah, and people think, well, those are just kind of ancient Greek myths, and they've been elaborated over time. You know, maybe they're apocryphal. But then you come forward to something like Évariste Galois, who was such a brilliant student of mathematics that his teachers hated him. His teachers couldn't deal with him. He was so advanced. And he abandoned school, and he got into a fight over a woman and was challenged to a duel with the finest shot in Paris. So he knew he was going to die the next day. He was 17 years old. And so the night before the duel, he wrote down all his mathematical theories. And in between the mathematics, you see these lines, I have no time, and a few words to this woman he's fallen in love with. And the next day, he is shot and he dies. 17 years old, and the mathematics that he created, you know, in the weeks before his death, are taught in every mathematics department in the world, and they're involved in the proof of Fermat's last theorem. So I think if you're an art student, there are great stories of passion and endeavour and dedication and so on. And I suppose what I want to say is that we have those same stories in mathematics as well. If you really get mathematics, it's a deeply moving subject, and we have our heroes and heroines as well.
Yeah. So I mean, this sparks my interest. But what sparked your interest? How did you become so interested in science?
I think it's... so my parents came from India in the 50s, and so I didn't really grow up in a household with very much music or literature, because they can be culturally specific, maybe. But science is kind of universal. And I grew up in a small shop, so we were always adding up coins and adding up money. And in about 1969, our whole currency changed, so I was involved in adding up numbers and converting. So I just grew up in an environment where I could learn a bit about science. And also, people were landing on the moon. And I suppose the converse question is how could anybody not be interested in science? How could people not be interested in the origin of life, in the incredible technology that allows these TV shows to be made, in the origin of the universe and what stuff is made of? And how can hydrogen and oxygen make this water that's on the table? These are incredible questions. I have a 4.5-year-old now, and you see it in a child's eyes. They want to know what happens if you stick stuff in the microwave and turn it on full blast. They want to know.
So do you do that with him?
Yes, we do that. Soap is a good thing. There are a lot of dangerous things you can do with a microwave, but if you put soap into a microwave, there are pockets of air in the soap, typically, and the soap warms up, the air expands, and the soap bubbles into a beautiful sculpture. So try that at home. I'd recommend it. It's safe. And it smells quite nice, so it's a good experiment to do. But children have this natural curiosity about the world, and I've heard other people say that people who love science are people that have just never lost that curiosity about the world around them.
Yeah. Well, you have this... this book is dedicated to your wife and to your son, Hari.
Yes.
And it's all Greek to me.
Yes.
I guess it's a code.
Yes, well, the Greek letters are... the first Greek letter is eta, and it's an eta, and my wife is called Anita. And the second one is
Sai.
which is short for Simon. So Anita plus Simon equals epsilon. And an epsilon is a representation in mathematics